Important information lecture part 2, part 1 of that. We're going to be looking at laws of matter. So this will be a very brief video here. So I want to cover 3-4 basics kind of background theory relating to matter, which are all things that we study in chemistry. The first thing, of course, which is one of the most important ones, is the law of conservation of matter. Law of conservation of matter says in a closed system, matter is constant. So if I have two systems here, let's say these are both the same system. This is before. This is after. Let's say I have some particles in here. Boom, I draw 9 of them. Let's say some of them come together and some of them do not. This would be 18 grams before. If it was conservation of matter, then after, I would still have 18 grams, assuming this system is closed. So matter is not going to change mass. I might rearrange and do different things, but I'm not going to lose or gain anything in this system for conservation of matter. Then on that note, we have the law of definite proportions, which is kind of what it sounds like, definite proportion. Elements will combine in a fixed kind of ratio. So all samples of a given compound, regardless of their source or how they were prepared, have the same proportions of their constituent elements. And so I love using the example of water. Water is H2O. We might know water as H2O, right? And I'm going to draw it like this. Let's say this is H2O, right? Boom. No matter what way I slice it, I will have 16 grams of oxygen for every 2 grams of hydrogen, or an oxygen to hydrogen mass ratio of 8:1. 8 grams of oxygen for every 1 gram of hydrogen. Always, always, always will tell me that I am H2O. So if I have a ratio that is, let's say I have 32 grams of oxygen to 4 grams of hydrogen. This is still 8:1. This means this is water. 8 oxygen to 1 gram hydrogen to 8, So if that mass ratio is always 8:1 in oxygen to hydrogen, then it is always water. The mass ratio holds true for any sample of pure water. If a sample had 15 grams of hydrogen and 12 grams of oxygen, there would be if a mass had 15 grams of hydrogen, there would be 120 grams of oxygen. And that's because 120 divided by 15 is the same as 8/1. So that is the law of definite proportions. No matter what compound I have, its mass ratio will be constant. Then some compounds could form in multiple ways. And this is the law of multiple proportions. So if two elements A and B combine to form more than one compound, the masses of B that can combine with the given mass of A are in a ratio of small whole numbers. So I have two compounds here that have hydrogen and oxygen. We have water, H2O, and then we have hydrogen peroxide. These are two different compounds that have hydrogen and oxygen. For water, we need 2 grams of hydrogen for every 16 grams of oxygen, or we know every 1 gram of hydrogen, we need 8 grams of oxygen. Same idea. For hydrogen peroxide, we'll need 2 grams of hydrogen for every 32 grams of oxygen. This ratio is a little bit different. This ratio is 16. So 1 gram of hydrogen has 16 grams of oxygen. This ratio is 2 times larger. This is the ratio of a small whole number that is referred to. This would be consistent with the law of definite proportions. 16 is 2 times 8. If I got something that was like 14 or 13, that would not be a whole number ratio, and that would not work. Another ratio would be if I had 48 grams of oxygen to 1 gram of hydrogen. This would be a whole number ratio there. This would be 3 times the amount that we normally have. That would be 2 grams. 24. Sorry, my math is a little bit off here. If you get the idea here, I'm trying to have whole number ratios. So if I had 24 grams of oxygen, this is 3 times larger. 24 over 1 would be 3 times larger than 8 over 1. All of these ratios that I have here, 8 over 1, 16 over 1, 24 over 1, the top number represents grams of oxygen. The bottom number represents grams of hydrogen. Looks like all of them have the same amount of hydrogen, but a different amount of oxygen. These numbers would be consistent with the law of multiple proportions. If I multiply by a whole number and I get that ratio times a whole number, then it is consistent with the law of multiple proportions. At the bottom here, we have Dalton's atomic theory. It's a little bit of an old theory, and you could read this. It's not really typically tested on the AP exam, but just keep in mind that in the early 1800s, this is what Dalton thought the model of matter or atom looked like. He thought that it looked like very small particles called atoms. Each atom of a given element are identical. So like all of these would be carbon, but then maybe something like this would be oxygen. Just as an example, they would look different, but all be the same circle. Atoms of an element cannot be changed into atoms of another element, so I can't turn carbon into oxygen. And then compounds are formed when atoms of more than one element combine. So this would be a carbon and oxygen compound. And so that ends just a very quick video here on the different laws of matter. What I'd like you to do now is, putting all of this information together, try and answer the first exercise here, having to do with laws of matter. And the hint that I'm going to give you is look at comparing mass ratios. Alrighty, that is all for part 1 of our part 2 important information lecture. If you have any questions or concerns, please let me know.